The objective for this video is to learn how to calculate a probability associated with a sample using the central limit theorem. In 2013, a Nielsen poll showed that among people aged 13 and older who play video games, the average time spent per week playing is 6.3 hours per week. Assume a standard deviation of 1.9 hours per week. If a random sample of 40 people who play video games were drawn in 2013, what is the probability that the mean hours spent playing video games for the sample would be greater than 7.1 hours? We must pay particular attention to the exact question that is being asked. We are not asked to find a probability associated with a single value. Rather, we are asked to find a probability associated with a sample of size 40. In order to answer this question, we must first understand the central limit theorem. The central limit theorem states that as the sample size increases without limit, the shape of the distribution of the sample means will approach a normal distribution. It is important to remember two things when using the central limit theorem. If the population is normally distributed, then the sampling distribution will be normally distributed regardless of sample size. If the population is not normally distributed, then the sampling distribution is approximately normally distributed if the sample size is at least 30. The sample size for this problem is 40, so we will use the normal distribution to approximate this probability. The question is asking us to find the probability that the sample mean is greater than 7.1 for the sample of 40 people. We will use a z-score to find this probability. It is very important that we use the standard deviation for the sampling distribution, also called the standard error of the means, when calculating a z-score associated with a mean of a sample. The standard deviation for the sampling distribution is found by dividing the standard deviation for the population by the square root of the sample size. So we will substitute the sample mean, population mean, standard deviation, and sample size into the z-score formula. This will result in a z-score of 2.66. So finding the probability that the sample mean is greater than 7.1 is the same in this case as finding the probability that the z-score would be greater than 2.66. It is always helpful to draw an appropriately shaded curve when finding probabilities associated with a normal distribution. Our z-score of 2.66 will be between z equal to 2 and z equal to 3. We are to find the probability that the z-score would exceed 2.66. So we will shade the region under the normal curve to the right of 2.66. Using a tool such as a normal probability table or a graphing calculator, we would find that the proportion of the distribution occupied by that shaded area is 0.0039. So the probability that the z-score would be greater than 2.66 is 0.0039. Another way to state this result is by saying, in the year 2013, among people who played video games, 0.39% of all possible samples of size 40 would have a mean number of hours spent playing per week greater than 7.1 hours. In this video, we learned how to calculate a probability associated with a sample using the central limit theorem.